This giant redstone contraption can save every single recipe in the game, using up to 23 kilobytes. 18 redstone ticks after inputting an item ID in binary, it will send the whole recipe within 20 redstone ticks over these 12 instant wires. Why would I need to save every single recipe with redstone, if I can just look at a recipe book in the crafting table? Well, if you've watched my previous video, you might know. In the 1.21 update, Mojang will introduce the Autocrafter, which allows us to do amazing things, like my project, the Creative Mode Computer. A system that will be able to craft and store every item, almost turning your game into creative mode. This is the first update on that project, and it will focus on storing the data of all recipes. At the end of the video, I will talk a little of what else has been done and our future plans. There are several ways to store data in Minecraft, and one of my favorite ways is using Music Disk, since that's relatively fast and very compact. If you want an example of how this works and how it can be used, watch my map printer video or RAM video, after finishing this one. Since I was already experienced with Music Disk, that is where the development started. But unlike my previous project, I didn't work on this one alone. In my last video, I explained my vision for this project. Then I said something at the end of which I didn't expect it would do much, but boy was I wrong. I'd worked hard on the video, so after finally posting it, I was exhausted, had some dinner and then went to bed, while messages were coming in faster than I could read. The next day was chaotic, with dozens of newly joined members discussing many different aspects of the project. I had not expected this at all, so it was a great feeling to see how many people were inspired and willing to contribute. Luckily, XPbot, OG and Spoopy were willing to help me manage the project. In the beginning, we mostly just set up systems to keep the project organized. We divided it into 8 teams. I started a server and made sections for each team. If you need a server yourself, you can click the link in the video description and get 15% off your first month using code MK. Most of the activity on this server was in the memory section. We started by making the lookup table, which stores all the recipe. Since this data never changes, we can use read-only memory. That means once the memory is built, we cannot change the data using Redstone. In this project, the lookup table consists of an item, followed by extra information about the recipe, and then 9 items representing the slots in the crafter. All items are represented by an 11-bit binary number. We started the development by using Music Disk to store this data. I made this prototype using my wall binary decoder, and Carrot, JFBN and SPRX2 worked on this prototype, which was even more compact. But then I realized that Music Disk might not be the optimal way to store data for a lookup table. There is another way of storing data that is much better suited for this application, and that's using walls and trapdoors to store data. Walls are awesome redstone components because they have a hidden feature. Walls can have several states, and the state change can be detected by an observer. This state change is instant, meaning you can send a signal from the top of the world all the way to the bottom instantly. You can use this feature to store data. If you activate a trapdoor and it closes against the wall, it will change the state, and that can be detected by an observer at the bottom. Then, by using trapdoors to represent 1 and none to represent 0, we can save a binary number and read it by activating the trapdoors. The advantages of this method over a Music Disk are it's stateless, thus improving reliability, and it's faster, which are priority number 1 and number 2 on this project. The disadvantage is it takes up way more space than a disk system. It was a no-brainer for me to go with the wall system, though not everyone on the team was quite convinced by this yet. This is the first prototype I made. As you can see, the size difference is enormous, but there was still room for improvement. The design had way more storage than required, and there was a way of building it more compact. So, after Carrot showed me this design made by Magic and Cribble, who already had shown me their design like half a year ago, which inspired the first design, I made a new design. Here, trapdoors still represent 1, but there are now fence gates representing 0. since they don't connect to walls and still carry a signal. In the final design, one recipe consists of 10 rows, each with 12 bits. 11 bits for the item plus 1 pointer ID. 9 rows represent items and 1 row is for metadata, like how many items the recipe outputs. We can also use the memory to save how items are produced that are not crafted. For that, 1 bit in the metadata indicates whether it is a crafting recipe or not. Then, OK Almond used this design and connected it to some RAM to test how it could work. The pointer ID is used to indicate whether an item can be crafted itself. If the pointer ID is 1, the item ID will be sent back into the lookup table, so its recipe will also be stored in memory and sent to storage. That way we can make sure that everything is crafted from the ground up. So instead of just using planks to craft a chest, we use logs, craft them into planks and send those planks to the crafter making chests. After seeing this prototype in action, the rest of the team was also convinced that the wall memory was the way to go. So I had to make 2 binary decoders, which take a binary number as input and only send a signal to the output assigned to that number. The lookup table has 6 modules that all have 256 layers. But since there are currently under 1300 items in the game, we will not use them all, and the final design might be a bit smaller. One binary decoder decodes an 8-bit number and sends it to one of the 256 layers. A second one decodes a 3-bit number and sends it to one of the 6 modules. Then there's an AND gate at every register. So only when a register gets a signal from the layer and the module, it will activate, then send data down the walls to the instant wires, which stores the data in RAM and sends it to the rest of the crafting system. Now, there were still 2 things that needed to be done. Over 1500 connections needed to be tested, and the lookup table needed to be programmed with actual data. The testing was done by adding redstone lamps at the end of a register, which turned on after that register had sent data. Then I added my binary adder counter to the input of the decoders and made it count from 1 to 255. Each number would be sent as a binary pulse over these 8 rails. Then I manually selected which module to test with the 3 last bits. At the first test, a lot of the lamps did not turn on or turned on multiple times, so I knew there was something very wrong. I suspected the vertical binary decoder, so I isolated it, tested it, and it confirmed my suspicion. On 1 bit, there was a repeater on 2 ticks when it should only have 1. And since I used World Edit to copy the layers, that mistake was repeated every 16 layers. So I fixed it, tested the decoder again, and it worked. Then I tested the rest of the connections again, and there were still some lamps that didn't turn on. But none of them got activated multiple times. So all I had to do was fix a few connections where 1 piece of redstone was missing, and then all 1536 lamps turned on, without activating at the wrong time. Great success. So, all we need to do now is store the actual data in the lookup table. Carrot already wrote a script for that purpose, so we do not have to do that manually. We just need to finalize the item ID system, which is dependent on the UI system. This is our current idea for the UI. 3 lecterns, where 1 selects the item category and the 2 others are used to select the item from an XY grid. You can locate items with these maps or by looking into the chest. Then, once you selected an item and the amount, the item ID will be sent to storage, and if there aren't enough items, the ID will be sent into the lookup table so they can be crafted. There are still a lot more things that were discussed, and prototypes that have been built. But that will be topics for another video. I will link them here once released. If you want to follow the development more closely, you can join my Discord server with the link in the description. And maybe even share your ideas and help with development. I'd like to thank everyone who's helped out so far. And thank you for watching all the way to the end. Watch this video next to see how useful music disc can be.